Okay, last problem in the exam. This problem is a combination of a couple of different circuits. In this particular version, there is a RC filter in combination with a limiter. In other versions, there was a dual limiter, which looks like this. Where this was +1 and this was -1, or a rectifier, which looked like this. And this basically, this R acts as a load for the rectifier. So the question is, once the sine wave is processed by the RC filter, what happens on the output diode circuit? If the result is a sine wave of the same amplitude, which in this case was 5 volts, it's a chance that the limiter would come into action and cause it to limit the output. If, however, the filter filters the signal down significantly, then it may not be acted upon by the limiter. On the other hand, if you have a version of the exam which used the rectifier, if the output was big enough to actually turn the diode on the rectifier, then the rectifier would rectify and give you half of the wave minus about 0.6 volt drop. On the other hand, if the filter attenuated the signal significantly, it's possible that there would be no signal that would get through the diode because I need that 0.6 volt drop in order to get through the rectifier. So the real question is, what is the action of the filter? Once you know the action of the filter, you can decide whether or not the diode circuit itself has any effect on the waveform. So we want to find again, the F3 dB point of the filter, which in this case is 1 over 2 pi times R times C. And I can write that as 1 over 2 pi times 0.047 microfarads and 1K. So depending on your setup, you may have a different filter. You may have either a high pass or a low pass, but the question is, what's F3 dB? In this particular case, I'll punch this up on my calculator. I have 2 pi 0.047 e to the -6 and 1000. That gives me 3386 hertz, which I round up to 3400. So I've got a 3400 hertz high pass filter and I'm sending in a 200 hertz sine wave. I know right away it's likely to be attenuated. So if you remember what the Bode plot looks like, I've got something that looks like this. I've got F3 dB is around 3400 and my sine wave is down here at around 200. So it's going to be cut off by quite a bit. How much? Well, 3400 to 200 is at least 1 decade. So there's greater than a decade. A decade is, remember, I have 20 times the log of 10 of V out over V in. 1 decade means that log of 10 has to be equal to -1 because I'm reducing the size of the signal, and that means that V out over V in is equal to 1 over 10. So I know that I'm going to have a output of the filter is going to be less than 0.5 volts peak. And that means that the filter itself is going to do nothing. Or the diode rather. The diode circuit itself is going to do nothing. So the diode does not limit in this particular case. In other cases, it did. So when the diode does not limit, that means that the waveform that comes out of the filter is unchanged. C-H-A-N-G-E-D. So the result is P. It certainly is smaller than the waveform that came in from the very beginning, but it is still a sine wave.